Okay, first off, thank you for tuning in. Second of all, thank you for understanding that this graph is going to have some boundaries. So if you're on your phone, I'm sorry, you may need to go to a computer and go full screen here in order to really see these numbers in this graph. But what we're going to be talking about is velocity versus time of some particle, right? And remembering that velocity tells us two things. Velocity is a vector and it tells us both the speed and the direction, the magnitude and the direction. So if I'm talking about two things, one thing has a velocity of -5 meters per second, and one thing has a velocity of 5 meters per second. They're traveling the same speed, but they're just going different ways. One is going left, the -1, one is going right. So we would look at the absolute value to know the speed, and we look at the sign to know exactly which direction it's going. Now, it could be talking about left versus right, or it could be talking about up versus down in the context of the problem. So just read the problem and know that context and be able to interpret what direction it's going based on that. So what I'm going to do is I'm going to annotate some things in here, tell you what I'm looking for when I'm thinking about these problems, and then I'm going to give you a problem to see if you can internalize those things and organize your thoughts there. So the first thing it says is, on what interval is the particle moving to the right? Okay, so key here is that we're moving to the right. So I know that in order to find this, I know that I will be moving to the right when the velocity is positive. Okay, because remember that 5 versus -5, right? The 5 meters per second would tell me I'm going 5 and to the right. So our velocity has to be positive here. So now let's actually look at our graph and see if there are any positive values for our graph, for our particle. Let's see. It starts off at a velocity of 0. So it starts off at rest. And then we can see that that velocity, even though we can't really zoom in and see what it was, maybe it increases to like 1. It doesn't really matter what the values are. We know that it's positive there, right? So from here all the way to 2, we can see that we have a positive velocity. But 2 is not positive. 2 actually goes back to 0. So if you think about the movement of this particle, it moves to the right faster than slower and then stops at a time of 2. And then we can see that it goes above the graph again. The graph goes back into the positives, I'm sorry. So that means that our velocity must be positive again. And if our velocity is positive again, that must mean we're also still moving to the right. And then we can see that it drops down below the axis, it meaning the graph. So that means the velocity must be negative. And then finally it meaning the graph is, the velocity goes above the axis again. I keep using the word it, and I'm going to tell you in a second not to use the word it, so I have to stop that. The velocity again is positive. Now we don't care if the graph is going up or going down. That does not matter. I'm really just looking not for the slope, but for the y values itself. So I'm really just looking above to tell me positive versus below to tell me negative. Right? Because all of those are negative y values versus positive y values. You're going to need both of these pieces of information today. So on what interval is the particle moving to the right? Okay, so this is kind of my annotation. I'm looking for where the velocity is positive. Right? And I'm going to use that in my example. So the graph is above the x-axis. And now, so we're going to go ahead and say that. So now this is an interval, which means I'm not talking about points anymore. Because if I had to define every point where it was positive, there's an infinite number of points in here, right? Think about dotting up this entire graph, right? There's a whole bunch of points that are positive. I want to just say from here to here. And to say from here to here, I'm just going to use the x values, right? So think about from 0 to 2 to 5. From 0 to 2, I'm going to use open circles here because it's actually not positive at 0. And it's not positive at 2. From 0 to 2, it is positive. So we're using those parentheses to show from here to here. And then from 2 to 5, it is also positive. Right? From 2 to 5. But notice how I'm not including the 0.2 and I'm not including the 0.5 because the velocity is 0 there. And 0 is not a positive number. And we skip a whole bunch and we see that the velocity doesn't become positive again until we get a time of 8. So at 8, and to the right of 8, our velocity is going to be positive. So I could say something like 8, and I can estimate what that x value is, but maybe I just want to use 8 to infinity, maybe this graph continues all the way to the right, or I can once again just kind of estimate, maybe say like 8.3 or something, wherever that value is. So I need to include a justification. So on what interval is the particle moving to the right? And maybe I'll use a full sentence here. The particle is moving right on the interval, blah, 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 right? 0 to 2, 2 to 5, and 8 to infinity. Because and I'm not going to say it, and I'm not going to say the graph anymore. I'm going to refer to one of two things. I'm going to refer to the velocity or the particle. So right here, I need to actually use the velocity to justify what the particle is doing. So the particle is moving right because the velocity of the particle is positive during that time. Right? And positive velocity tells me a positive movement to the right, a positive direction. So use that and think about the exact opposite for the left, right? That would be anytime velocity is negative. So now let's look at this next question. At what time, so I'm looking for an actual instance, does a particle change direction? So when does it change direction? So when does it go from left to right or right to left? This is just kind of me rewording the question here. So when I think about something like this from left to right, I'm thinking from neg to positive or positive to negative. And I'm not talking about the slope again, because slope actually tells acceleration here. I'm talking about the y values, right? So it's got to actually change from, below to above or above to below. And let's see if that happens in this graph at all. And this time I'll annotate this with purple. It starts above, goes back to 0, goes back above, so it goes right and then it stops, and it goes right and then it stops again. And we see it goes below, so it must change here from positive to negative. So we see that positive to negative change, right? That's going to be a change in direction. The particle actually went from the right to the left, and then it's going left this entire time. So it's going left fast, 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 slowing, slowing, slowing until it stops here. And then it goes back, the velocity goes back to a positive. So it's going from right to left to right. So it's actually changing at the particle is changing direction at two different moments. And so we're not using an interval here because it's not changing direction from here to here. It's actually changing at an exact moment in time. That moment in time would be t equals 5 and t equals 8. And we know this, so we can actually now build a full sentence. The particle changes direction at t equals 5 and t equals 8 because, and I'm going to now refer to the velocity. Velocity changes from positive to negative, or vice versa, right? And then lastly, okay, so that's kind of just changing the direction. And then this last one is going to ask us, is the particle speeding up or slowing down on the interval 7, 8? So what I'm going to do is I'm going to clear all my annotations on that graph. And I'm just going to take a look at kind of like a restart here. And just including the interval 7 to 8. So here's 7, here's 8. It's just telling me the x values, not a point, but x values. And it says specifically interval, not point. So basically from here to here. Now we want to know what's happening here. Is it speeding up or is it slowing down? Well, remember, just because a graph is going up doesn't mean it's speeding up. We really need to think about the velocity. And let's actually think about what that velocity is. That velocity is, let's see, it's counting by kind of like ones here. So we could call that like a negative 14 as the velocity. And at 8, the velocity is 0. So let me ask you this. Which is faster, negative 14 or 0? Now I know that negative 14 is smaller. But remember that the velocity tells us the speed plus the direction. So this is really just going 14, but it's going 14 to the left. And this one is going 0. That's no movement. So we're going from basically some speed to no speed. Well, we know that we must be slowing down. So the particle is slowing down on 7, 8. Because the velocity is approaching 0. Okay, and we know that because it's going from a speed of 14 to a speed of 0. Anytime we have a velocity that is closer to 0, right, 0 is the slowest we can go. So if the number approaches 0, that must mean our speed is approaching 0. So now it's up to you to kind of take this information and again, kind of internalize it and see if you can reflect on it and add it to question number 3 on the next page. And I'll just kind of walk you through what else I'll be looking for. I'll be looking for question number 3 is kind of a redo of that problem. And then question number 4 is matching. So you'd have to say, okay, if the particle is slowing down, what do I know? Okay, well, I know, okay, if the particle is slowing down, let's see, that doesn't tell me the velocity is negative because that just tells me it's moving left. Okay, if it's slowing down, it must be approaching 0, a velocity of 0. Velocity approaches 0. Okay, and I can match those two things together. And it's just a matching activity. Let's see, number 5 here is just identifying compound interest. So you just got to identify from this problem. This is one I should walk through with you as well. Your different variables in this equation, have this written down for the test. Identify those variables and plug them into a calculator very carefully in order to do so, in order to really evaluate it. So in something like this, the principal amount, your P, is just how much you start with. So it actually is going to go in order, but that won't always be the case. 2,000, and your rate is your interest rate. So 3%, but we need to write that as a decimal. So we're going to write that as 0.03. Remember that we moved decimal places over 2 places from 8% to a decimal. Number of times compounded per year. So not the number of years, but compounded per year. So we have an annual interest rate of 3%, but it's compounded monthly. Well, there's 12 months in a year. And the number of years is going to be our T, which is in this case going to be 10. So it's just a matter of us making sure that we have all this information and that we evaluate it properly. So our I, our interest, is going to be 2,000, our principal, times 1 plus our rate divided by n, so 0.03 divided by 12, all times, all to the power of n times t, so 12 times 10. And just simplify some things first. So in a problem like this, I'm absolutely going to work inside those parentheses first, and I'm going to do that division. I'm going to do that fraction inside those parentheses first. So the first thing I'm going to do is 0.03 divided by 12. And let me just do that on my calculator. I think I remember what it was, but I don't want to get my my decimal in the right spot. It's 0.0025. So I have 1 plus 0.0025, right? I've just kind of evaluated just that fraction on the inside. And I could also do this outside first, right? 12 times 10 is 120, knowing that I'm going to eventually have to take it to that power. And I would just continue to evaluate the inside. And this is the mistake that so many students will make, is they'll take this and they'll plug it into their calculator, but their poor calculator does not know order of operations. So they'll actually do 2,000 times 0.10025 and take that number and raise it to 120. But we have to be smarter than our calculator here. And we have to make sure that we raise it to a power first. All right, so you might see something in your calculator that says like x to the y power or a to the b. And that's exactly what you want to use to evaluate this. So I'm going to type in 1.0025 and I'm going to raise it to x to the y, 120. You could also use your Desmos calculator or any calculator on the internet. And you will get 1.349353 blah, blah, blah. Okay, I'm not going to include that whole thing, but I'm going to take whatever that number was in my calculator. I'm going to multiply it now by 2,000. And this is what we're going to get. 2,698.7070, blah, blah, blah. Now, I'm not going to use this as my answer because it actually says to round it to the nearest cent. So I've got my dollars in here. I just need to go 2 decimal places. But remember that that 7 is going to round it up. So my final answer here is going to be, let's see, $2,698.71 because that is rounded to the nearest cent, to the nearest hundredth place. And that would be my answer using compound interest. So once again, your principal, your starting amount, your rate turned into a decimal. The number of times, you're going to have to do some thinking here. Monthly, right? Quarterly, hint, hint, wink, wink is 4. And then number of years. Okay. Make sure that you solve inside first. take the inside raised to the power, and then you multiply by your coefficient. You will be perfect. There's your answer for that one. Go ahead and do number 6 and number 7. Submit that for your extra credit. Thanks for tuning in. See you out there.